So I know, like, the last video is kind of weird, talking about making 5 devices that spin fast with water to element and these biblical constructions and stuff.
Operator, put me through to Quebec. Lord William Penrose. Yes.
So I want to talk about construction today. I want to talk about, I want to revisit the Olympic flag and go over that long, tedious derivation, so that'll be at the end. But,
He's addressing a meeting of the Royal Canadian Occult Society at a Quebec hotel.
It's urgent, sir.
you know, like, it's kind of hard to imagine that I think this is possible, which is why I related it to fiction earlier, but,
Page?
Yes, sir?
Lord Penrose, Lamont Rouge is on the telephone. It's urgent. It's in the Gold Room.
Yes, sir.
no, I want to show you, another example of it hidden in plain sight would be Sherlock Holmes clip.
Gentlemen.
That I just showed you, and I figured,
As you know, the greatest obstacle in proving the authenticity of the occult lies in finding facts.
gotta have an open mind is kind of implied there, so, as zany as it might sound, it's still magic and the occult, and
However, if the facts are there,
it's all your lore. It's all the stories that have ever been told in every mythology or point in time, BC to AD to FG, you know, whatever.
even the most hardened skeptic, provided it has an open mind, must finally acknowledge the actual existence of the supernatural.
So, yeah, it's a tough pill to swallow to see what I think is possible. Like, I get everything that's going on in life, but I'm just saying, like, what I think is possible with the power of word and everything, and the power of number is just, I figured Sherlock Holmes would be the best place to start with that.
Do you admit that, Mr. Holmes?
Facts always convincing, Lord Penrose. It's the conclusions drawn from facts that are frequently in error.
Today is Monday. It's finally, hopefully not going to be freezing. But, yeah. I got, like, round 2. It's mostly flowers for outside that are perennials, so they can, you know, have a chance next year. Like, these look cool. I wonder what that means. Anyway, yeah, last few videos have been strange. I don't know, it's been all positive. Like, that looks good. And the like, kind of way I want to talk about this. Like, I'm not, like, you know, this is what happens here. I'm not too sure how to respond to that one. Yeah. That one means a lot, because of the video it's on. Anyway, I don't know what wow means. I don't know what that means. I don't know what that guy's name means. Oh, this is a giant crate, like, that's from an old video. Anyway. Right. Okay, we're done. So, you know, I'm sitting here going, kind of went off the deep end on this one a bit, right? You know, this one I show you an observation of the pattern of math that I see everywhere. So I figured let's do a little bit of a recap. You know, because, like, when you understand words, you can destroy someone with their own words, right? So let's look at the book of words, I thought. Dictionary, because I was going through these old books. I was looking for something, I still haven't found it. But, yeah, dictionary. And that one's close, too, thesaurus. So, Alt, Tab. Yeah. I won't say words. Well, I will. But those are the numbers for the letters. Top row would be the order. I put a space in there just to kind of emphasize it. But this one's dictionary is pretty easy to understand. You know, like a 4 is a circle 3, and 9 is a circled 8. A 3 and a 2 is a 5, and you have a circle for it, and then that's circled 8. And here, in this row, I got a circled 8 here and a circled 5 here. And I got this 5 to 1 code that could be circled. So 5, 2, 1 is 8. And circle it is circled 8, and a 4 is a circled 3. And then for thesaurus here, well, right away, the is 385. And then you have a 19, okay. But what I did was I took the 1 from the 19, the 1 from the 1, and I just turned the 21 around and took the 1 from it, so I have a 13, an 18, and a 15 with a 9. And that'll be your circle 3, circled 8, circled 5, circled 8. And I move that 2 over to here. So the 2 is beside this stuff that's been carried forward. 2 and a 1 is a 3. It's next to an 8, a 2 and a 1. Oh yeah, the 9 I broke into a circled 8 because I wanted to take that 1. Sue me. 3, 8, 2, 1, 1, 1 is 5 and 8. 3, 8, 5, 8. So, thought that was interesting. Again, you know, thank you to the algorithm. Apparently I had to see Just Like Heaven. And of course the guy's got a 5-pointed star in his guitar. Say nothing more, you're being inducted to the Rock and Roll Hall of Fame because you know maybe something. You're kind of like, come on, Heaven and the Star Guitar. Star Guitar is a goddamn song from I think Chemical Brothers. How about Star 69?
They know what is what, but they don't know what is what. They just strut. What the fuck?
Star Guitar. That might be Fatboy Slim. Yeah, Chemical Brother has Star 69. Fatboy Slim has Star Guitar. Anyway.
They know what is what, but they don't know what is what. They just strut. What the fuck?
Okay. 1 of 1 of 7 of 13 and of 110 of 2143. I found a really good one of that today. So this one I didn't do too long ago, so the video is like pretty high on the list, so you should be able to find it and go through it and then discern whether or not you think this is accurate. I found this one. This one's pretty hard to beat. I think there's 2 in this book. This is a good book, whatever book this one is. Alright? So this one, all I want to look at is, that's all I want to look at right now. 3.14159. Everything else, whatever. Okay? All the assumptions are here, and these are the changes. And blue and the red signifies what's left. Like, everything's blue here, then everything goes red, but then the blue are used. So anyways, 3.14159 is a pretty much universal digit of pi. The point is a 2 because it's a 0 with a slash through it, signifying an elliptical or a 69 or an 8 or whatever, an 88 or 888. It's a 0 and a slash. Okay, any planet that you look in the sky with a telescope, it's going to look like a swirling elliptical. You don't see planets in the sky, guy. So if we change this to this, okay, and then we just reorder it from like smallest to biggest, it's kind of neat. It goes 1, 1, 2, 3, 4, 5, upside down 6, right?
They know what is what, but they don't know what is what. They just strut. What the fuck?
So let's just do that. Let's say if a black 9, which is this, like it's a 9, we're a circled 6 because like they're kind of like equivalent. They match.
They know what is what, but they don't know what is what. They just strut. What the fuck?
So just make one more assumption here. Put that 6 in there. You gain a bubble, and the 6 is what I'm talking about. So now, if we take that, and then take the 2 first ones, that could be your 1 of 1 of. Okay? The 7 could be the N6 with the bubble itself. So I turned it black here. The 6 and the bubble are black because the circled 6 is a 7. Then your 2, 3 here. Well, if I want to get a 13, I'd have to circle. Well, I could take 1 from the 2, so that's what I did. A 2, 3 is a 13 circled. So I put that there. So I have a circle within a circle. So maybe what's in the circle doesn't really matter at this point. Now since 1, 1 circled 13 is just 110 of, because we don't look in the circle, just the the circle. That would be your 110. So you have your 1 of 1, of 7, of 13, of 110, and your 21 are going to be leading to the circle would count for the 1. You have a 4, and a circled 5, 6 is just a circled 11, which is a 3. For 21, 43.
What the fuck?
1 of 1 of 7 of 13 of 110 of 21, 43 is represented from a certain point of view as 3.14159. If you make that dotted 2, and you make that 9 a circled 6. And then you make that 2, 3 a circled 13. It's all equivalent. It's all matchy-matchy. Oh yeah, then I just want to get back to the importance that how the Olympic flag is like the instruction manual on how to build the thing I want to build from a certain point of view if you look at all the details. So I'm just going to read it, and I'm not going to really go much past it. So this is your Olympic flag. You have 3 rings. You have your V, Y, X axis, and you have 2 rings. It's kind of like I'm going from Luke to Vader now. A different lightsaber. Anyway. 2 rings are your W and Z axis. That's your 3 spatial coordinates for 3 dimensions, and these are your 2 eyes of the observer. The 2 receiving analog lenses, let's just say. And I'm gonna kind of figure out how this Armageddon code of 14560, where the blue would be the 1, the yellow, which would be second, would be the 4, the black would be the 5, the green would be the 6, and the red would be the 0. So there are 32 magnets per ring. So each of these rings, okay, when in the center of the cellular energy device, you're going to have 1, 2, 3, and 1 on the angle, 1 on the angle. Those are going to have 32 magnets, like, on the inside of the ring. So 32 times 5 is 160 magnets. Now depicted are 5 rings and 9 white holes. Represents the 14 axles for the 6 faces and 8 vertices of a cube. There is a magnet at the end of each axle. 14 magnets, because there's 14 axles for the 6 faces and 8 vertices. So 160 plus 14 is 174 magnets in heaven. This is how we're going to get to 3858. So 174 is part of that. That's one step. That's one size of magnet. That size of magnet that has to be inside these rings is the same. And possibly the same size at the tip of the axle. Probably the same size. Because they're going to be bar magnets. I think they're like 5 mil radius. I don't remember. Anyways, the base construction of the cell would have 6 large wheels on the faces and 8 smaller ones on the vertices. Not only squaring the circle, squaring a cube. So, we have looked at the rings and the white spaces. The next complex point of view would be looking at the 1x2s. Okay, so these are all a bunch of linking chains. Like that's a 1x2, that's a 1x2, that's a 1x2, that's a 1x2, that's a 1x2. Like there's lots of 1x2s. There are 7 unique 1x2s. They look like 8s. That's a 1x2, 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 that's a 1x2. Where to start? Okay, so you have 7 unique 1x2s. They look like 8s. Well, 7 8s is 5 6, 5 6, 7. Anyways, using the Armageddon code above. Oh yeah, so the blue. Okay, so if the blue are 1s now. So blue is equal to 1, and you have 2 blues in this depiction. So you have 2. Yellows are going to be your 4. So you have 1, 2, 3. So 4 times 3 is 12. Blacks are going to be your 5. You have 1, 2, 3, 4. 5 times 4 is 20. Greens are going to be your 6. Okay, let's not move up there. 6 times 1, 2, 3, 18. Reds are going to be your 0, which is a 2. I guess that's an assumption. 1, 2. 2 times 2 is 4. Anyway, if you sum them up, these and these are 22 and these are 34. 22 and that's 6, 56. 14 circles sums to 56. Dot dot dot. So 56. Yeah. Okay. Let's just leave it at that for now. I'm just setting something up, I guess. Yes I am. 56 is an interesting number associated with 1x2s. We have already covered the 5 rings and white holes. 56 minus 5 minus 1. So 5 rings, and because they're holes, I guess. I don't know. 50. Also, 7 plus 8 is 15. Backwards 51. Okay, 7 plus 8 is because the 56 comes from the 7 unique 8s. Right. So the 50, okay, so this is what I'm trying to get at. Let me say this better. I'm talking about 56 total sum in the 1x2s, which are made by... Yeah. I hate these books. 7 unique 8s. Oh, there's 14 circles. Oh, that's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, that makes more sense. Okay, there's 14 circles and they sum to 56. That's a lot more interesting. 14 circles. 14 circles sum to 56. Okay, need to be getting more familiar with what I'm doing. So there's a lot of lot of association with the Armageddon line. And, well, if you understand that it goes 1, 4, 5, 6, 0, the one on top is also a 0, so that could also be your 50. Maybe that's why there's 50 magnets per wheel. And 14 wheels in the base cell, so 50 times 14 is 700 total magnets. Read it backwards as your 007 James Bond. There are 7 unique 1x2s made from 2 rows of zeros. We've covered that in the last page. 1, 4, 5, 6, 0. 14 circles summing to 56. 14 plus 56 equals 70 with the 0 at the end. Again, suggests 700 magnets needed for the wheels. Way number 1. Way number 2. Black is not a color. So 700 again is if you have, that is per base cell of wheels, because you have let's just say there's one wheel on every face and side and vertice. Face and vertice. That's what we get. But we're going to see if it's more complicated. So black is not a color of light, okay? So it's just not. Go Google that if you want. Therefore, there are 4 colors in 2 8s. Now we've made 2 unique 8s. We went from creating 7 8s to 2 8s. Each wheel is made with an exterior and interior ring. Okay, this is my kind of assumption. Your 8 looks more like a snowman instead of a classical 8. Remember, the top one's always supposed to be smaller than the big one. Anyway, the reason being the interior one would have 8 magnets on the interior facing, outwards, facing this way. And the 42 on the interior would be facing the other way. Thus, when you put your solenoids here, and you rotate your wheel, and your solenoids are stationary, and they're being held from the bottom, and the wheel's turning around them, then that works. So, a 1 is a segment. I apparently wanted to say that. A 0 is equal to a 2 for here. Oh, okay. I get it now. it's depicted in the thing. Seeing this as a segment, it's like we're accounting for this and this, but that one in between is not being accounted for. So that one is the missing one for the 42. And here, if you know that that is a circle and a slash, then that's your 6 and 2 is 8. So there's your 42 and 8. Ugh. If dot is the blue ring and dot is the yellow ring, the one would be the slash. Yeah, okay, you have 4, this, yeah, and a slash. I'm talking about 42. Blue and yellow light makes white. Okay, so blue and yellow light makes white light. Blue and yellow light makes white light. Or get rid of it. Get rid of the circle is what I'm saying. It's like a circle 42. Get rid of it. Because this goes away. 42 magnets is where event like we think we see in white light. Alright, the Olympic flag logo went from this to this, from this. Okay, so what we've just said here is that we've gotten rid of this and the black now, and all we have is a 42 in a white circle. We have a white circle 42, and then we got the black one, because, you know, the black is still there, but it's not a light. And then we have this 8 over here, because, did I put it here? Red and green light makes yellow. Yes, okay, I did. So this becomes yellow now. I should really follow my own instructions, eh? So this is a new thing. We have a white, a black, and a yellow 8. Like per each wheel. We know that black is a 5 and yellow is a 4. Ah, yes, from the original. This is the 5 color from here, and this is a 4. 1, 4, 5. 4, 5. 5, and 4. If this is a 5, it's also it's a circle already. So if it's a circle, it has to be a circled 4 as a 5. And because this one's an 8 already, but this is actually a 4, you have to depict it in, like, say, a 4, but with 2 circles to get the 8, because it's 4 twice. So I've changed this to this now. I didn't have the 5 here, but I knew it was 5. So converted to proper units, colorless units, 42 plus 4 plus 4 is 50, plus the circle for the 4 is 51, plus the double circle for here is 53. And I think, you know, we just need our double 8s. Excluding the hole, excluding the white hole, so excluding the thing that should be not seen, but you know is there, you can make 2 unique 8s, because you have an 8 one way and an 8 the other way, with the big and the little bottom circles. So there are your final 8s for 3858. Anyways, 53 is interesting since there should be 3 wheels on each axle for the 6 faces. So where the wheels are bigger, there's going to be less of them. But on the vertices where the wheels are going to be smaller, there should be more of them. And this is actually my assumption. This is 3 on the 6 faces and 5 on the 8 vertices for balance. Conversely, 5 rings total, 3 rings total. So again, this is showing you again, kind of like what I was thinking the cell has to become in order to be balanced. So now we have this flag is now this, okay? This is yellow. No, it's all white now. We got rid of the colors or something. Yeah, we got rid of the letters. So read left to right, top to bottom. So if you go left to right, top to bottom, we're going to go blue, black, red. 3 rings. We have an 8 from one of these 8s. Then we have, I don't know what that means, 5 rings. Yeah, okay, you read all the rings as 5 rings and then 3 rings. I don't know what that 3 rings means. I know that there's 2 8s here. We went from this to this. We went from having a 3 of 5 to 2 8s. This is all I'm trying to say, I guess. Anyways, again, the 6 faces of the cube have 3 wheels per axle. The 8 vertices of the cube have 5 wheels per axle. Total wheel magnets, my god, that took so long. So 6 faces times 3 multiplier times 50 is 900. these would be the vertices. The 8 vertices times the 5 wheels times the 50 magnets would be 2,000. The total is 2,900 magnets. 2,900 magnets from the previous found 174 would be 3074 magnets so far. And also we have this going on, has a lot of interesting numbers. It's like basically a circle. Maybe the 5 is being pushed to make room for the slash. You know, there's different ways of looking at it. Working backwards. Red, then green. Again, red and green light make yellow light. So the red and the green will go backwards, I guess. You're left with blue, yellow, and black, yellow. Okay. You're left with blue and yellow and black and yellow. Remember, in the circle slash, this becomes black and yellow from the 5. 5 is black, yellow would be the red and the green, and then your blue and your yellow. Anyway, this becomes this. And if you want to make it balancy, let's say, okay, so the 4 is touched. Okay, if you want to bring the 4 and have it touch the white of the blue here. So if you want to, this 4 is not touching anything. It's only touching the 5. If you want to swing it around and have it touch this, you have to reduce the 5. It creates balance when it's in a cell. You have to now contain it if you reduce it. So that's all I did. I took this depiction and I reduced this by 1 and I made it balanced as best as I could and contained it in cell notation. The final magnets needed in the construction of the cell are for the box kite. Yeah, okay, so the 3 types of magnets we've covered so far are the first ones for the interior of the heaven structure or the firmament structure. And then we have the faces, or the big wheels. They're going to have bigger magnets, and then the vertices are going to have smaller magnets. And now we're going to talk about these square magnets, the cube magnets. They're going to make a cube, like a box kite, with 4 faces of the thing, are going to have a grid of 14 by 14 magnets. So that's what I'm going to talk about. So the final magnets needed in the construction of the cell for the box kite, which in cases the cell, these magnets are used for voltage. Okay, you can get 3 volts from nothing, no amps. Anyways, we need 3858. We have this, so we need this 784 number. Looking at the above diagram, I see 4 of the 6 faces of a cube encased. Top and bottom are not encased. I should have said depicted. So, again, 1 face, 2 face, 3 face, 4 faces. You don't really see this, and we don't really see this. The top and bottom are not encased. So basically, you have your grid here, grid here. That was really badly done. So, if you take 14 times 14 times the 4 sides, you get your 784. So I think you need to space out, like you got like a cube magnet, and it's gonna have a insulator material between it, and then it's gonna have a coil, and that coil is gonna be in an antenna, and that distance is gonna be the spacing for your 14 by 14 grid. All the way around. So it's got to be rigid but not, and it's going to be basically the same height as everything going on inside. So I'm not too sure what the total is yet, because I haven't really looked at it like that yet. Anyway, you need 3,858 magnets, 4 types: face, wheels, vertice wheels, heaven, and box kite for 1 cellular energy device as Olympics. Now it doesn't really talk about the whole. Well, I think there's 5 of them. Well, that's 5, and that's 5, and that's 5. And that is 12. But then you have 13, 14, 15. Just saying.